All right, so here is the review for test number 3. All right, so number 1 says the height in feet, y, of a ball thrown by a child is y equals negative 1/2 x squared plus 4x plus 6, where x is the horizontal distance in feet from where the ball is thrown. Draw a picture to represent the situation, and I want you to label it. How high is the ball when it reaches its maximum height? What is the horizontal distance of the ball when it reaches its maximum height? How far from the child does the ball strike the ground? Between what distances will the ball be at or above 10 feet? All right, so let's draw a tiny picture. You should plug that in your calculator. And when you plug it in your calculator, your picture looks like this. So we have here, we have x is the distance in feet. And we have y is the height in feet. Okay, so when you graph it, your graph looks like this. Goes up, and then it comes back down. All right, so I have to label a little bit more with my picture. All right, but I need to start finding some things so that I can label. So let's find the maximum height here. So plug it in your calculator, do second calc. We're looking for the max, do left bound, right bound. And this point here is 414. Which means that it reaches maximum height at 4 feet from the child, and its maximum height is 14 feet. Okay, so let's write that down. So its max height is 14 feet, and the horizontal distance at its max height is 4 feet. Okay, so the next thing we have to do is how far from the child does it strike the ground? So I'm looking for this point here, which is my 0. Okay, so do second calc, number 2. Do left bound, right bound. And this point is 9, 3, that x value. Okay, so it strikes the ground. 9.3 feet from the child. Okay, so the next thing I want to do is find between what distances will, just wanted to read this. So what distances will, the ball be at or above 10 feet? Okay. All right, so I want at or above 10 feet. Okay, so 10 feet would be about here. Right, so I want y is equal to 10. Right, here's 10 feet. Okay, so I want at or above. So I'm looking for this point here and this point here. All right, so do second calc, number 5, intersect. Do both of these, and then this point is, so it'll be at 10 feet at 1.2, and then it'll be all above 10 feet here until we get to this point and at this point. So do second calc, intersect again, and that's 6.8. So it'll be at or above 10 feet between 1.2 feet is less than or equal to, and it's less than or equal to because it says at 10 feet. And then one above, x is less than or equal to 6.8 feet. Okay, so let's take a look at number 2. Okay, so number 2 says, what are the most zeros and extremas a polynomial function of degree n can have? So if it has an n degree, it has at most n zeros. So if it's a degree 5, it has at most 5 zeros. And it has at most n minus 1 extrema. So if the degree is 5, it has at most 5 zeros, and it has at most 4 maxes and mins. Okay, let's take a look at number 3. So it says f of x is equal to x to the third, and g of x is equal to x minus 2 to the third minus 2. So it says state the transformation and graph both. So I'm not going to graph both. I won't show you the graph. I'll just actually show you a quick graph over here. So f of x should look like this. All right, and then we have minus 2 to x means to the right 2. And minus 2 on the outside means down 2. So that should look something like this. So it's going to be to the right 2 and down 2. So it'll look like this and like that. Okay, so let's take a look at number 4. Okay, so the leading coefficient test and talk about what happens at the end behavior. Okay, so 4A. All right, so we have a degree of 3, which means it's odd. And my leading coefficient is negative, negative 4. Okay, so on your graph, since it's negative and it's odd, it'll go up to the left and down to the right. So that means as x goes to negative infinity, f of x goes to infinity. And as x goes to infinity, f of x goes to negative infinity. Okay, let's take a look at 4b. All right, my degree is 4, which means it's even. And my leading coefficient is positive 1. Okay, so since it's positive and it's even, it'll go up, up. All right, so as x goes to negative infinity, f of x goes to infinity. As x goes to infinity, f of x goes to infinity. Okay, let's take a look at C. All right, C, the degree is 5, which means it's odd. And the leading coefficient is positive. Okay, so on your graph, since it's positive and it's odd, it goes in different directions, so it goes like this. All right, so as x goes to negative infinity, f of x goes to negative infinity. As x goes to infinity, f of x goes to infinity. Okay, and D, the degree is 2, which means it's even. And the leading coefficient is negative. It's negative 5. Okay, so since it's even, it goes up, up, or down, down. Since it's negative, it goes down, down, like this. All right, so as x goes to negative infinity, f of x goes to negative infinity. As x goes to infinity, f of x goes to negative infinity. Okay, let's take a look at number 5. Okay, so number 5 is you have to write the polynomial function. So they give you these zeros. And these are rational zeros. So we have x is 2 and x is 6. So let's write that. X equals 2 and x equals 6. Since they're rational, you could do backwards factoring. So this is x minus 2 equals 0. X minus 6 equals 0. So it's x minus 2 times x minus 6 for my factors. Double distribute, we get x squared minus 8x plus 12 is equal to f of x. Okay, so let's try 5b. So my zeros are x is equal to negative a half, x is equal to 3, and x is equal to 2. Okay, so to get rid of the fraction, we'll cross multiply. So we get 2x is equal to negative 1, so 2x minus plus 1 is equal to 0. We have x minus 3 equals 0, and x minus 2 equals 0. All right, so I have 2x plus 1 times x minus 3 times x minus 2. And I'm going to start with these two because those two should be the easier two. So we get x squared minus 5x plus 6. And now I have to multiply that by 2x plus 1. All right, so when I multiply, I get 6, positive 6, negative 5x, positive x squared. 2x times 6 is positive 12x, and then I have negative 10x squared and positive 2x to the third. So my polynomial f of x is equal to 2x to the third. X squared minus 10x is negative 9x squared. That's x squared minus 10x is negative 9x squared. And negative 5x plus 12x is positive 7x, and I got plus 6. And don't forget, it has to be f of x equals. Okay, let's take a look at number 6, which is the division. Okay, so the number 6 is using long division. Okay. All right, so we have 5x squared minus 17x minus 12 divided by x minus 4. Okay, so x times what gives me 5x squared? That would be 5x. Multiply down, we get negative 20x and 5x squared. Subtract. The 5's cancel. 5x squared cancel, so I have plus plus. So it's negative 17x plus 20x is 3x. Bring down the minus 12. So x times what is 3x? That would be 3, positive 3. So multiply down, we get negative 12 and 3x. Subtract. So I get plus plus there, that cancels, and I get 0. So remember, so my quotient is 5x plus 3. So remember, when you have a remainder of 0, that means that this is a factor and this is a factor. They're both factors of this. So if I factor this polynomial, I will get these here. Okay, so let's take a look at the next one. 6b. So that's x to the 4th plus 5x cubed plus 6x squared minus x minus 2 divided by x minus 2. All right, so x times what is x to the 4th? That's x to the 3rd. Multiply down, we get negative 2x to the 3rd. X to the 4th, subtract. So we have 5x to the 3rd plus 2x to the 3rd is 7x to the 3rd. Bring down the 6x squared. So x times what is 7x to the 3rd? That would be 7x squared. So multiply down, we get negative 14x squared. And we get 7x to the 3rd. Subtract. Those cancel, so we have plus plus. So we get 6x squared plus 14x squared is 20x squared. Bring down the minus x. And then x times what is 20x squared? That would be 20x. Multiply down, we get negative 40x and positive 20, 20x squared. Subtract. The 20x squareds cancel. So I have negative x plus 40x is 39x. Bring down the negative 2. And then x times what is 39x? That would be 39. So multiply down, we get negative 78. 78 and 39x. Subtract. The 39s cancel. And then when I get plus plus, I get 76. And that's my remainder. So I write it like this. So it's x to the 3rd plus 7x squared plus 20x plus 39 plus 76 over, this is your remainder, 76 over x minus 2. Okay, so let's try 7a. Okay, so 7a is to write the quadratic function in vertex form, identify the vertex and the axis of symmetry. Okay, so remember, vertex form is f of x is equal to a times x minus h squared plus k. hk is the vertex and x is equal to h is the axis of symmetry. Okay, so let's take a look at a. All right, so a is f of x is equal to negative 4x squared plus 24x minus 41. Okay, so I'm going to complete the square. So I'm going to add 41. So it's f of x plus 41 is equal to negative 4x squared plus 24x. Divide everything by negative 4. So I have f of x over negative 4, or negative f of x over 4, minus 41 over 4 is equal to x squared minus 6x. All right, now I do half of negative 6 is negative 3, squared is 9, add that to both sides. So I get f of x over negative 4 minus 41 over 4 plus 9 equals x squared minus 6x plus 9. And then this side, the right side factors, becomes x minus 3 squared. And then when I combine my terms, I get f of x over negative 4 and negative 41 over 4 plus 9. So you can plug that in your calculator and get negative 5/4. Okay, so add 5/4 to both sides. I'm just going to move everything up a little bit. Okay, so I have negative f of x over 4 is equal to x minus 3 squared plus 5/4. All right, so now to get rid of the negative 4, we have to multiply by negative 4. Both sides, make sure you distribute. So that cancels out. So we have f of x is equal to negative 4 times x minus 3 squared. And then negative 4 times 5/4, it will be negative 5. All right, so my vertex is 3, negative 5, and my axis of symmetry is x is equal to 3. Okay, so let's try 7b. All right, so that is g of x is equal to 1/2 x squared plus 8x minus 1. All right, so I'm going to add 1 to both sides, so I get g of x plus 1 is equal to 1/2 x squared plus 8x. So to get rid of the half, we have to multiply everything by 2. So I get 2g of x plus 2 is equal to x squared plus 16x. Now we do half of 16 is 8, squared is 64, add that to both sides. So we get 2g of x plus 2 plus 64 is equal to x squared plus 16x plus 64, and then that factors and becomes x plus 8 squared. And I get 2g of x plus 66 equals x plus 8 squared. So minus 66 from both sides. So I get 2g of x is equal to x plus 8 squared minus 66. Divide everything by 2. We get, I'm just moving everything up, g of x is equal to, there's really a 1 in front, so it's 1/2 x plus 8 squared minus 33. Vertex would be negative 8 comma negative 33, and the axis of symmetry would be x is equal to negative 8. Okay, so next, number 8. Let's take a look. We have find the quadratic function that has the indicated vertex and whose graph passes through the given point. All right, so we use the same formula. All right, we're going to plug in our vertex and our point. So remember, our formula is f of x is equal to a times x minus h squared plus k. So my vertex is 3, negative 6, and my point is negative 1, 2. So remember, this is hk, and my point is xy. So I'm going to plug in hk, and I'm going to plug in xy. Remember, when you plug in h, it's opposite. So my f of x, which is y, is 2, equals a, that's what I'm going to solve for, times x, which is negative 1. My h is 3, so when I plug it in, I get negative 3, squared plus k, which is minus 6. So it's 2 equals a times negative 4 squared minus 6. 2 equals positive 16a minus 6. Add 6, we get 8, equals 16a. So a is equal to 1/2 when you divide both sides by 16. Now we just write the equation. F of x is equal to a, which is 1/2, times x minus h, which is going to be minus 3, squared plus k, which is going to be minus 6. Okay, let's try 8b. All right, same formula. F of x is equal to a times x minus h squared plus k. Vertex is 4, negative 4, and my point is 110. Remember, hk, xy. Okay, so let's plug in. My y value is 10. So I have 10 equals a times x, which is 1, minus h, which is 4, squared, minus 4, which is k. So it's 10 equals a times negative 3 squared minus 4. So negative 3 squared is 9. So it's 10 is equal to 9a minus 4. Add 4, I get 14 equals 9a. Divide by 9, a is 14 ninths. So my equation is f of x is equal to a, which is 14 ninths, times x minus 4 squared minus 4. Okay, so let's take a look at number 9. Okay, so number 9 is synthetic division, so we want to find the quotient using synthetic division here. Okay, so I'm dividing by x minus 1. So remember, you change this to it's 0, which is 1. You put down all your coefficients, which is going to be 2, 6, negative 14, and positive 9. Okay, so you start by bringing down the 2. And then you multiply 1 times 2, you get 2. Add straight down, we get 8. 1 times 8 is 8. Negative 14 plus 8 is negative 6. 1 times negative 6 is negative 6. And then 9 minus 6 is 3. That's my remainder. Okay, so I started off with an x to the third. So that means this is going to be have an x squared. So it'll be 2x squared. And then now it goes down in order. Plus 8x minus 6 with a remainder of 3. So it'll be plus 3 over. And then my divisor, which is x minus 1. Okay, let's take a look at 9b. So 9b, my divisor is x plus 2. So that means I'm going to have negative 2 on the outside with 5. I need a 0 for an x squared, 0, a 6, and an 8. Okay, so I start by bringing down the 5. So I have negative 2 times 5 is negative 10. 0 minus 10 is negative 10. Negative 2 times negative 10 is positive 20. 6 plus 20 is 26. And then negative 2 times 26 is negative 52. And then 8 minus 52 is negative 44. And that's my remainder. All right, so I started off with an x to the third. That means this is going to have an x squared. So it'll be 5x squared minus 10x plus 26 minus 44 over x plus 2 over my divisor. Okay, so let's try 10. Okay, so 10 says, using the intermediate value theorem, find all intervals of length 1 in which the polynomial function is guaranteed to have a 0. Show your table of values. Okay, so you're going to plug y is equal to 3x to the fourth plus 4x cubed minus 3 into your calculator. Look at the graph to see where it crosses the x-axis so you know which table of values to write down. Okay, so I'm looking for a change in my y values. So I'm going to go from negative 2, negative 1, 0, 1, 2. At negative 2, I have 13. At negative 1, I have negative 4. 0 is negative 3. 1 is 4. And 2 is 77. So I have a change here. That means there's a 0 in between negative 2 and negative 1. So between these two. And I have a change here, which means there's a 0 here between 0 and 1. So we would write in the 1 unit interval of negative 2 to negative 1 and 0 to 1, there exists a 0. Okay, so let's try 10b. Okay, same thing. You're going to plug it in. Plug this guy in. Look at your graph to see where it's crossing the x-axis so you know which table of values to write. Okay, so I have to actually go from negative 4 to 4. So negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. All right, so I have 98, negative 7. At negative 2, it's negative 22. Negative 1 is negative 7. 0 is 2. 1 is negative 7. 2 is negative 22, 3 is negative 7, and 4 is 98. Okay, so I have a change here. That means there's a 0 here. I have another change here, so there's another 0. Another change here, 0. And then I have a change here, which says a 0 here. Okay, so in the 1 unit interval, negative 4 to negative 3, negative 1 to 0, 0 to 1, and 3 to 4, there exists a 0. Okay, and last one would be 11. So let's take a look at what 11 says. It says, explain what happens to the graph of a polynomial function that has a multiplicity of 2, which is even, an even multiplicity, and a 1, which is an odd multiplicity. Okay, so when I have an even multiplicity, the graph will be tangent to the x-axis at that 0. When I have an odd multiplicity, the graph will cross the x-axis at that 0. Okay, so that's it. And, study. This will be the last test for the quarter. Last grade I have for you guys. So study and have a good night. See you tomorrow.